You can build an MCP server in 10 minutes. You can also build a 10-minute security hole that lets an agent read the wrong files, call the wrong operation, and hide the evidence inside a friendly tool name. The protocol is not the dangerous part. The dangerous part is confusing a standard connection with a safe capability. Start with the problem MCP solves. Without a shared protocol, every AI client needs a custom connector for every external system. One client talks to GitHub one way. Another talks to a database another way. A third invents its own plugin shape. Add more clients and more services, and the connector count grows into a grid. MCP, the Model Context Protocol, creates a common boundary. A host contains the AI experience. A client inside that host maintains a connection. A server exposes selected capabilities. The model can discover what is available and request an operation through a typed interface. An MCP server can expose three main things. A resource is readable. File-like context, a document, record, or API response. A tool is an operation the model can call, normally with an approval path. A prompt is a reusable template that helps the user perform a particular task. Those categories matter because reading a document and deleting a deployment are not the same kind of power. So let us design the smallest useful server, a project status server. It exposes one resource containing the project policy and one tool called getBuildStatus. The tool accepts a repository identifier and returns the latest known branch, commit, result, and timestamp. Notice what it does not expose. There is no arbitrary shell command. There is no raw file path. There is no execute query field. There is no tool named manage project that hides 20 unrelated actions. The input schema should be narrow. A repository identifier can be validated against an allow list. The response should have a stable shape. Failures should be explicit, and the server should return only the fields the agent needs for the next decision. That is the first security rule. Design capabilities, not tunnels. An arbitrary shell tool is a tunnel. The model supplies a string and the server runs it. Every validation problem is pushed into one dangerous field. A getBuildStatus tool is a capability. It has one purpose: constrained inputs, a predictable result, and a clear audit event. The second rule is to separate read from write. Reading status can often be pre-approved inside a trusted project. Restarting a deployment changes state and should be a different tool with a separate permission decision. Deleting an environment should be another capability again, with stronger confirmation and a reversible process where possible. Do not use one Boolean called dangerous to describe everything. Name the action so the human can understand what approval means. The third rule is to keep secrets on the server side. The model does not need the database password. It needs the answer to a defined question. The server retrieves its credential from the environment or a secret manager, performs the operation, and returns a filtered result. Never place the secret in a tool description, prompt, error message, or normal log. Now choose the transport. For a local server, standard input and output is common. The host starts the server as a child process and exchanges protocol messages through the process streams. This is simple and keeps the server local, but there is a wonderfully small trap. Normal logging to standard output can corrupt the protocol stream. The official MCP guide warns developers to send logs to standard error or a file instead. One innocent print statement can make the client report mysterious broken messages. For a remote server, an HTTP transport changes the threat model. Now you need real authentication, authorization, encrypted transport, tenant separation, timeouts, rate limits, and protection against replay or confused deputy behavior. It speaks MCP does not supply any of those controls automatically. The fourth rule is to treat tool descriptions as part of the interface, not as security. A description tells the model when a tool is appropriate. It does not prevent misuse. Enforcement belongs in code. If a tool says it reads only the current repository, the server must verify the repository boundary. If a tool says it cannot write, its implementation should not have a write-capable credential. The fifth rule is complete observability. For each call, record the tool name, validated target, caller identity where available, result class, duration, and approval outcome. Do not log secrets or unnecessary private content. The goal is to answer what capability ran, against what scope, and what changed. Then test failure, not only success. Send an unknown repository. Send an empty identifier. Send an overlong value. Simulate an upstream timeout. Return malformed data. Deny the operation. Disconnect halfway through. A server that works only when the demo path is perfect is not a production integration. There are also cases where you should not build an MCP server. If one application calls one internal function and no external client needs discovery, a normal function call is simpler. If a service already has a stable API and your agent framework can call it safely, adding another protocol layer may not create value. If the operation cannot be bounded or audited, turning it into an agent tool does not fix the design. And if a human must perform a regulated approval in a specialized interface, keep that interface in the loop. MCP can prepare evidence without impersonating the approval. So the production checklist is short. One tool, one purpose. Typed and validated inputs. Least privilege credentials, read and write separated. Human approval matched to actual consequence. Secrets kept outside model visible data. Structured results and explicit failures. Correct logging for the chosen transport. Audit events for every meaningful call. And test for denial, timeout, malformed input, and boundary escape. MCP is valuable because it gives clients a shared way to discover and invoke capabilities. It can replace a mess of custom connectors with a clean protocol boundary. But the protocol boundary is where security begins, not where security is completed. The best first MCP server is boring. It reads one useful thing, exposes one narrow action, fails clearly, and makes every permission visible. Build that first, then add power one capability at a time with evidence that the new capability is worth the new risk.